Surprisingly enough, I started working as soon as I got this idea. Fresh equals JSON.oh. In this video, I make a Python program that auto-clicks through any level in Friday Night Funkin'. How did I do this? Well, for every level in the game, there is a JSON file that contains a lot of details of that level, including which notes to press. Here's how it will work. First, it will open the JSON file of a level and read it. Then, it will work out which notes to press and how long to wait in between each note. And finally, it should auto-click through the entire level. The first thing I did was I copied and pasted all these files into my Python project. And like so, I started coding. I needed to import three things. First, the PyAutoGUI library, and by the way, I automated my online classes with it. It's pretty cool. Second, the sleep function, and third, the JSON library. Okay, so the first thing that the program needed to do was loading the JSON file of the level. Now, I had a very vague understanding of how to use the JSON library. I knew what I was doing, but I didn't know if it was going to work. Okay, so here's the file of the level fresh. As you can see, there are some details at the beginning, but the things that matter are the numbers right below. Each note was a list of 3 values. Now, I noticed that the value in the middle was always in between 0 and 3, so that probably represented the arrow that you should press. If we follow the order in which the arrows appear, numbers 0, 1, 2, and 3 are equal to left, down, up, and right, respectively. On the other hand, the first value was the time in which the notes appeared, since it was always increasing. Here, I made a mistake by overcomplicating things. I thought that those units were some form of divisions of the beats, and thus were related to the amount of BPM of the song. However, it turns out that they're straight up milliseconds, but we'll get to that later when I realized that I made the mistake. The first few notes of the level fresh, the part where you beatbox, those are mostly eighth notes. Now, in the JSON file, the notes were increasing by an amount of 250, so that meant that 250 units were an eighth note, and thus 2000 units were a full bar, or a section of the song. After some complex maths, I came up with an equation that converted the amount of units to the amount of seconds, according to the BPM of the song. The next thing that the program had to do was to iterate through every note. Now, I knew that the notes were grouped in sections. Instead of making the code iterate through every note, I made it iterate through every section first. Then I added the iterations for every individual note. Now, in the JSON, there is a parameter called mustHitSection. It is a Boolean value that tells the game if the player should play the part or not. And so I added the condition so that the code only iterates through the notes if it's the player's turn. For example, these notes shouldn't be considered because they're dad's notes, not boyfriend's notes. To do some testing, I made it print out the second in which the note appeared, and also the arrow that should be pressed. And as you can see, I used right here my function that converted units to seconds, but again, that function ended up being useless. But enough talking, it was time to run the code and see what happens. It worked, or at least it appeared so. For example, the first notes here are down, down, right. And indeed, those are the notes that appear first to the player. After iterating through every note, how would the auto-clicker know what to do? Well, my idea was to make a list called instructions. You can think of it as a simplified version of the JSON file. However, instead of having the times in which the notes appeared, these instructions would have the times that the autoclicker should wait in between each note. That meant that I had to subtract something. I didn't quite have it right the first time, but I corrected it later. And I knew that something like this would give me an index error during the first iteration, so I made a try statement. Keep in mind that this was mostly wrong. I wasn't meant to subtract some value of the instructions, because it was already subtracted. What I should be subtracting is the time that had passed before the note. I realized that I needed to come up with some way of timing the auto-clicking so that it doesn't start right after I run the program. And that was a problem that I didn't want to face in that moment. So I just placed a prompt to press enter and I called it a day. I also didn't quite remember the names for the arrows in the PyAutoGUI library, so I checked them out and they were left down upright in lowercase. And this last for loop will be in charge of all the auto-clicking. It will have only 2 lines, one for the waiting and one for pressing the note. I promise that the boring parts of this video are almost over. Now I had to think of some way of activating the auto-clicking. It wasn't that simple, but my first idea was to make the program recognize something from the screen whenever the level starts. And the one thing that appears in every level is the Go text. So I took a screenshot of the game and did all the necessary pixel measurements. I wasn't sure if this method was going to be reliable at all, but I had the idea because I had already done it before when I automated my online classes. There is this function that returns true whenever a pixel has the color values that you want. With that out of the way, it was time to do the first proper test in the game.
3, 2, 1, go!
That's right, it did nothing. However, once I paused the game, I noticed that it did move. Only when I paused the game. So I got all my hopes up and continued. I realized that I was very wrong with my subtraction, so I made this variable that always kept track of the time value of the previous note. And with that, I didn't need the try statement anymore. I ran the code and got this. What was causing that, I didn't know, but I checked the JSON file and there were numbers that had time values that were smaller than the ones before them. So yep, that was the cause of the error. And I had to make a condition so that notes were added only if its time value was larger. This had the disadvantage, however, that the program would probably miss some notes. It was time to do some more testing.
3, 2, 1, go!
And again, nothing. So I got back into the drawing board and decided to change this so that instead of looking for the Go text, it looked for the black screen that appears before the start of the level. Basically there was no difference, the only difference was what note it got right. A friend told me that this game was not so good at recognizing fast keyboard clicks, so I made it so that it made a longer press. However, I had to compensate that wait by subtracting that amount from the sleep command. Now I ran the code and it worked. Half the time. The results weren't consistent and the game was aware of that. Also, I noticed that everything drifted. At the start of the song it was okay, but as the song progressed, it became way off. So it was a problem with the waiting times. I needed to try something else, so I tried my luck and downloaded all these libraries that checked for user input, but I had no clue on how to use them. I eventually gave up on that and decided to test other levels. I adjusted the variables accordingly and I tested the tutorial, it was okay. And after that I tested south. And I don't remember why, but I checked the JSON file of that level and saw this. I was very confused since I thought that these values were divisions of the beat. There was no need for the values being that specific. This wasn't jazz or anything, and then it hit me. These weren't relative beat values, these were absolute time units. If the level fresh had some very exact units, it's because it was 120 BPM, which is a very exact BPM number. That is, 2 beats every second. And like so, I realized that the values that I was seeing were plain old milliseconds, nothing more. Now that simplified a lot of things in the code. However, I ran it and it did some things I cannot understand. I tried some other levels and they all threw this weird error. And I was very worried because I didn't know anything about the JSON library. Until I discovered this monstrosity of null characters at the end of a lot of the files. I didn't know why they were there, if it was something that happened in the game development. What I did know is that there were thousands of them. Like 10,000 for every file. And I wasn't going to remove them manually, so I made a code for it. After that I tried MILF, and the times where it was pressing were way off. So I decided, yeah, I need another method for activating the auto-clicking. I copied and pasted this function from my online class automation, which basically does a spotlight search to change apps. My plan now was that the program searched the app, started the level, and waited the right amount of time so that the clicking starts. And I wasn't very confident of using this method because, you know, loading times, they vary in time. And spoiler alert, this method wasn't good either. Some time passed until I finally accepted the fact that this was not a reliable method. And then the definitive solution came to my mind.
3, 2,
By
1,
pausing right at go, I could ensure that the times were always the same, or that at least they were more precise. I knew it wouldn't get any better in terms of the activation method, so I focused now on tweaking all the waiting times. I made a list for all the waiting times for every level. Now in theory, it should always be 60 divided by the BPM, that is, wait 1 beat. But in practice it isn't, apparently. And I think it's because some changes in the BPM. In MILF, I think there are some at the start. Now at this point in the project, everything was tweaking values and seeing what happens, trial and error. After a while, the issue with the waiting times was solved. However, there were 2 things left. First of all, we still haven't programmed the sustained notes, and also, drifting is still an issue. So anyway, I got back to work on the sustain, which is this third number I have been ignoring the whole time. I added a sustain argument to my function, which had a default value of 0, and I was very concerned about the times that it would take because it would impact the drifting a lot, and thus I avoided the use of if statements and instead used this boolean statement in the middle of the operation so that it only adds the 0.06 seconds if the sustain is 0. I added the sustain parameter to the for loops so that it gets added to the list of instructions. I also needed the program to remember how long did the previous sustains last, because they also needed to be subtracted from the waiting time. I was subtracting so much off of the waiting times that it ended up having negative values, and of course that gives an error, so I made this boolean condition again so that it only waits some time if this subtraction gives a positive value. So I did some testing with Bo Peebo, and it was okay at the start, and then it drifted away. This drifting was way worse than the normal drift. The solution was quite simple. I just made it wait a little bit more whenever there was sustain. However, tweaking these values, that's the hard part. And it got way worse. Eventually though, I fixed the drifting, I tweaked all the values, and this is the end result. I think it cannot get any better. Before I end the video though, I want to show you two more things. The first being a quick breakdown of the entire final code, in case you want to do it yourself or in case you want to improve it. And it has a lot of room for improvements. And after that, I'm going to end the video with a showcase of the level Roses in hard mode. In my opinion, that's one of the most difficult levels. And here you go. So first, I'm going to break down the code. First things first, the three imports that you need are PyAutoGUI for auto-clicking, the sleep for waiting, and the JSON library. This prompts you to type the level, and this is the offset. Basically, it is the amount of seconds that are subtracted from the waiting times down here in order to correct the drifting. Then the JSON file is loaded in this line right here, and it is put back in another file with some indent so I could read it better. This last thing is completely optional though. Now this assigns the BPM, and this is the array of arrows. I repeated it a second time because sometimes the value was bigger than 3. After that comes the array of levels. Now the only purpose of this array is to have a way to index the amount of initial wait that the auto clicker needed for each particular level. By default, it should be 60 divided by the BPM, the time between the go and the start of the song. However, it was better to make my own specific values for each particular level, and so that's why we need the level names. After that, the list of instructions is declared along with these two numbers that we'll get to later. And then comes the Spotlight function. Its purpose is to switch to the Friday Night Funkin' app. Now you will need some other method if you're using another operating system. And after that comes the press function. As you can see, it presses a key down, it waits some time, and then gets the key back up and waits some more time. Now in case there's sustain, the sleep in between is going to change, and also the sleep after is going to be a constant value. Now after that, the program does all the JSON reading. It will only add a note to the instructions if it is the player's turn, that is, if the must-hit section is true. For every note, it appends to the instructions the time of the note, but it subtracts the time and the sustain of the note before it, so we always have a relative value. It also adds the arrow that you should press and the amount of sustain of the current note. When that's done, these variables are updated so that the current note becomes the previous note, and then the auto clicker is ready. It waits some time, it switches to the Friday Night Funkin' app, and then it presses enter to resume the game. Now it waits the initial wait that we already declared. I don't exactly remember what the 0.06 meant. Let's just pretend it doesn't exist. Now this last bit of code is what does all the auto-clicking of the level. It is either doing two things. It can be waiting for the next note, or it can be pressing the note. Now remember that we subtract the offset, so we correct the drifting. And here we're using the press function from before that takes in the key to press, the time to wait, which is 0 in this case, and the amount of sustain. If it's a normal note, the sustain will be 0. Now I'll show you the level Roses in hard mode, done entirely by my computer. As I said, this program has room for improvement. For example, it would be way more precise if it did everything in a more async manner. That is, instead of pressing something and waiting some time and pressing something else, instead of that, if it knew at what time to press what. Or it could be a mixture of both async and sync. I mean, each level is divided in sections, so you could tell the program to start a section at a certain time and then run every section in a sync manner, not async. And it will be like, I don't know, just improve my code. It also has the thing where it misses some notes. That issue can be fixed by adapting the program, which is the obvious solution, or by changing the order of the notes in the JSON file. Now enough talking, enjoy the rest of the level. Make sure to show some love to the video. I literally had to uninstall some apps just to make space for the footage, which is a certified Apple moment. Okay, so video's over, see ya.